So welcome everybody to today's session. Today's session is going to be introduction to networking, and our mentor is going to be Mr. Victor. So Victor, I don't know if you are in the session right now. If you are, just unmute yourself, and then the floor is yours. Thank you.
Hello.
Yes, we can hear you, Victor. You may proceed.
Hello. Okay. So my name is Victor Mwai. I'll be taking you through the introduction. I'll just do a recap of what I was doing. I hope, am I allowed to share my screen?
Yeah, sure thing. Feel free to do so. It's your class, so do whatever you want. Cheers.
Okay. Okay, I hope you can see my screen.
Yes, we can.
Okay, I'll just show you a recap of what I did. So a brief introduction of myself. I'm Victor Mwai, also known as Victor Noob. I play CTFs with Perfect Truth. Yeah. Then the agenda. Okay, so I took you through the introduction to networking in as the video in YouTube you saw. So I will show you the three-way handshake, the OSI model, TCP/IP, and then the importance of networking in cybersecurity. Okay, so what's a network? You can say a network is just a collection of interconnected devices. Think of it like you could think of a network in a layman's language, like the community hack it. Each person in the community is like an endpoint. You could think of it like, let's say me, Victor Mwai, I'm a laptop, Karim is maybe a desktop computer, and then we have a router, etc. So a network is just a collection of interconnected devices that communicate and share resources, just as I have defined here in the slide. And then some importance of networking. In cybersecurity, it aids penetration testers in identifying scope for penetration testing. So the first point is actually very critical because for a point of view, a pen tester, if you're given a document to look at it and then you're given a set of IP addresses, for someone who has never done networking, you will see the numbers, the network IP addresses, just random numbers on the paper, yet it's like they are defining borders of where you can do your pen test and where you can search for vulnerabilities in an organization, meaning there are certain devices you will be allowed to touch, because in our network devices are identified by IPs. The same way we humans, let's say Kenyan citizens, are identified by ID numbers, national identification number. So my ID number is different from another member, and like that. And then it helps in designing secure network architectures. By secure architectures, I mean you could think of an organization, let's say like Vodafone in Tanzania. So for the organization, they have a network that has been put in place that aids in identifying the devices in the network and how communication takes place throughout the organization. And then it also aids in network monitoring and threat detection, because this one it comes to be of importance in terms of digital forensics and incident response. Let's say an organization is attacked by a ransomware. You could identify the first point where the attack got into by identifying the IP address of that device. And then after an IP address of the device has been identified, the entire subnetwork that contains that IP address could either be put aside for further investigations so that the ransomware attack will be remediated and then acted upon. And then it also aids in incident response, just as I have said. Maybe an organization has been attacked by ransomware. The devices which have been attacked, they will get to be identified through their IP addresses. Yes. And then I gave a brief examples of networks. Examples, we have the local area network, metropolitan, and the wide area network, and then the wireless local area network, and then the personal area network. I think I'll brush through so that we can have questions because I've already uploaded the video on YouTube. And then this one was of great importance, the three-way handshake between a TCP client and a TCP server, so that you can understand how a communication is established in a network. So I will use the example just as I used in the video. Let's say the TCP client, it's me, Victor Mwai. Then the TCP server is Karim. Okay, we have gone to an event, and then I found that Karim is in the event, and I want to communicate with him. So first, I'll just introduce myself. Hello, my name is Victor Mwai. That is a scene scan. I have sent an hello get to the TCP server, and then Karim will answer back. Hi, Victor. Nice to meet you. A scene arc packet is sent back from the TCP server, the TCP client. And then me as Victor, and then I say, wanted to communicate to you about so and so. Yeah, so I have sent back an acknowledgement packet. And from that brief introduction, we can continue the communication with Karim freely and seamlessly. So with the three-way handshake, it usually helps in establishing the fast connection between the TCP client and the TCP server so that the communication can go on smoothly in a network. Sorry, I'm having a cold. And then we can look at the OSI model. It has 7 layers, as you can see in this diagram, from the physical layer all the way to the application layer. It usually has all this data from the physical layer all the to the application layer encapsulated in the packet. Like, so from the physical layer where the data is transmitted in raw form, bits, the data link layer, where the data is then embedded with another data within this data link layer, all the way to the application layer. So that is on the side of the client. Now on the side of the sender. So on the side of the receiver of the communication undergoes something called decapsulation, where the packet is being decoded all the way from the application layer up to the physical layer. The data that had been encoded initially from the receiver's end, from the physical layer out to the application layer, now gets to be decoded layer by layer by layer by layer up to the last physical layer. And then the TCP/IP model is just a small summary. It's a summarization of the OSI model, as you can see. The application layer, it's a combination of the session layer to the application layer, just put into one as an application layer. The same way to the physical and the data link layer, connected into one to form a network access layer. Then we'll just look at a brief introduction of protocols and standards. So for anyone who is new, protocols, you could think of it as a set of rules that aid in the way communication should be conducted in a network. So I just to help on the physical layer, we have the physical structure, and mostly here it's the cables, coaxial cable, fiber optic, and many others that act as the protocols on the physical layer. While on the data link layer, the protocols are Ethernet, and the network we have IP. IP it's just Internet protocol, ICMP, it's the packets that we usually send. Let's say I'm in a network, my device, I want to know if I can reach Google. I will send ping request to the Google server 8.8. And then the response that I will get from it, that's what we call an ICMP request. And then we have the transport layer that has TCP and UDP protocols. So the difference between the two is that TCP it's connection oriented, while UDP it's connectionless, meaning it's like wireless. It's like Wi-Fi. For communications to happen in a TCP, there should be a connection. Think of it like, let's say, an organization. Every workstation is connected to the network through an Ethernet cable that is connected to the computer. Whereas UDP, you could think of it, let's say an organization has a place for the guest. We have a wireless access point. Now the devices of the guest communicate with the wireless access point through UDP protocol. Then we have the session. Session here we have APIs, sockets, and many others. And then the presentation layer, we have SSL, SSH, IP, IMAP, FTP, and MPEG. And then on the application layer, we have HTTP, FTP, IRC, SSH, DNS, and many others. This is just a brief of the network hardware and media. You could, this is not that important in the part of cybersecurity. However, you need to know it because there are different forms of attacks that happen. So on the types of transmission media, we have two types. We have guided and unguided media. The guided media is the one that is mostly of cables. We have twisted pair cables, the coaxial cables, optical fiber, and the strip line, micro strip line too. And then the unguided media, we have here signals and waves. We have the radio waves, microwaves, infrared. Infrared, a good example of it, you could think of it like you are at everyone's, I guess everyone here has a television set at their homes. And to control this television set, you need a remote. So your remote communicates to the television set through an infrared wave so that you can be able to change channels on the television set. And then those are just a few examples how a twisted pair looks like. And a coaxial cable, and then a fiber optic cable. For the twisted pair, it has two forms of connections to an RJ45. We have the straight through and a crossover type of connection. And then the coaxial cable has only one. The coaxial cable, a good example of it, here in Kenya, I don't think they are already in use. How can I put it? We have, yes, television sets. Let's say in my home, I have a GoTV decoder, and then it has an aerial. So we have this coaxial cable that is connected at the back of the TV set and then connected to the aerial so that you can be able to search for signals for us to be able to see channels in our television set at home. A brief of troubleshooting, just as I said, the ping command. Our command line utility used to test the connectivity between our source device and our destination device. And then the trace route is usually used, for example, let's say you want to know how youtube.com is accessed from your laptop. Trace route is usually, it helps in identifying the hops. By hops, I mean each point where network communication happens. I think this will be better if I showed you in a demonstration. And then ipconfig and ifconfig. Ipconfig is for Windows, whereas ifconfig is for Linux or Mac OS. These two usually help in displaying details of devices network connections that it has. Yeah, that's all. I think we can have questions as I do the demos.
Perfect. Thank you very much, Mr. Victor, for your ample time and for your short demo that you've given us. So I think I'll give room for the mentees to ask questions. If you have any question, please feel free to raise your hand. And yeah, we'll give you the opportunity to unmute yourself and ask your question. So feel free to do so. Anybody? So if you have any questions relating to networking, so you can also write it down on the chat if you feel that you are shy to speak. So Victor, there's a question for you from Kevin. I think you can see it on your screen. So he's asking, is there a big difference between ARP and ICMP protocols?
Hi, Kevin. Oh, yes, there's a difference between ARP and ICMP protocols. ARP in full, it's address resolution protocol, and this aids in, ARP aids in putting, let's say, in my web page, I get to access youtube.com. What you're seeing here is just the name. Now the ARP, what it does, behind this youtube.com, there is an IP address, right? So what ARP helps in doing, we have and a MAC address. So an ARP is in putting the two together. And by this, what do I mean? This is my laptop, right? I'm connected to a different network. But what remains constant in my device, it's my MAC address. And a MAC address, it's a unique identifier for all devices in the world. And they usually have parts. The first 3 octets usually identify the organization that made the MAC address. And then the last 3 show the device's ID, how it's different from the other. So an ARP aids in mapping an IP address to a MAC address, if I'm not wrong. And then the ICMP protocols, just as I've shown you here, what you're seeing, the ICMP usually helps in mostly doing the network troubleshooting and checking if communications between devices in a network are possible. Just like I've done here right now, I have pinged the 8.8 server, so to see if I can be able to reach it. And as you can see, we have received 4 packets, and we have sent 4 packets with 0% loss, meaning we can be able to communicate with the Google Server 8.8.8 freely from our network.
Hello.
Hi.
Would you mind to repeat, please?
Okay.
The steps.
Pardon, repeating the steps on?
The last one, now what you're doing, and from Microsoft, how you displayed it, the last. Okay. Yes, this one.
He's talking about the ping.
How you committed first, yeah.
So you just type ping, and then the IP address for the Google server, it's 8.8.8.8. However, Google server doesn't have only one IP address. It has many, and I'll explain to you why it has many. So now you can see we have sent 4 packets from our IP address through the router to the internet so that we can be able to reach the Google server. And we have a loss of 0%, meaning we can communicate with it freely. Is that okay, Isaac?
By the way, these packets now, the 4 packets, yeah. 4 received. I mean, they said packets sent 4, received 4. Even I don't understand those things. What are they all about?
Okay, what they are all about, packets sent. It means from my device, I've sent 4 packets. Okay. In Windows, it's different. For Windows, the ping usually sends 4 packets. But for Linux, you have to specify the number of packets to send. You could say, let's say, like being number of packets to be 10, IP address 8.8.8. You see, it will send 10 packets. And as you can see, we have sent 10 packets. The Google server 8.8.8 has received 10 packets, meaning the communication now is well established between the server and my device in my network. That's why you are seeing sent packets 10, received packets 10. Is that clear?
So there is no interceptions or no error there?
Yeah, meaning our network connection is okay and we can communicate very well with the server.
How can I notice if it has been intercepted?
Or if this has been intercepted?
Yes.
One way you could notice is whereby you see the replies you have sent here.
Yes.
One could fail. One of the packets may fail, or you could find that we have sent 3, they have gone, and then the rest fail.
Oh.
Yeah.
Okay, thank you. Thank you so much.
Welcome. Kelvin, is your answer well answered?
Yes.
Okay.
I think I was referring ARP in terms of it is a layer 2 protocol, layer 2, while ICMP was in layer 3. That is the network. But your explanation has really given me more information. Thank you.
Okay. Welcome.
Thank you all for your questions. Anybody else who want to ask Victor any question, feel free to either shoot it on the chat or unmute yourself and ask your question as Mr. Isaac did previously, while Victor is continuing with his demonstrations.
Okay. I was to show you. Do you have any other questions, or I continue the demonstrations, or I can just do them while you ask?
I think there is no questions as for now, so you can just proceed.
Okay. So on the slides, I had shown you something called traceroute. So this is the command. So let's say traceroute 8.8.8.8. Trace. Trace. I think I'm typing it wrongly. Trace. Traceroute. So what you're seeing happening on the screen currently, we are tracing the route to this server 8.8 from our network. Okay. So my router's IP address is 192.168.88.1. These are the number of hops that are happening currently from my device so that it can be able to reach the Google server. We're having over a maximum of 30 hops. The number of hops you're seeing here, it's happening one after the other. So this is the hop from my IP, from the router in my network, the first one. Then these are the private IP addresses, trace complete. So this is what has happened. I've sent from my device, but what is being recognized in the internet is my router. So the hop comes from my router. This is it. Goes to this next hop. Then the rest up to where it now reaches the DNS Google server, the 8.8. So traceroute technically shows how communication is happening and what devices are being contacted for the communication to be well established. Traceroute in layman's language, you could think of it like I'm working in Hackett, right? So Karim is my boss. So before I reach Karim, there are certain levels or a number of people I should talk to before I go straight to Karim. But if I do go straight to Karim, I will have broken a certain number of protocols because before reaching to my boss, I have to talk first to maybe he has a secretary. The secretary, maybe the boss only talks to his personal assistant. So from the secretary to the personal assistant, like that. Or from my department, let's say I'm working in the IT department. From IT department, I'll go to talk to my manager who is managing me. And then from my manager, the manager talks to the head of IT department. Then the head of IT department will go to the secretary, to Karim, so that he can relay the message to Karim. Is that okay? The other command that I was to show you is the ipconfig. So for my device here right now, ipconfig, it has shown the number of network interface cards connected or connected in my network or for my device. I have a wireless LAN adapter because I'm using a wireless connection. I have a router. I don't need a cable. So my wireless NIC card has been given an IP address of this 192.68.88.20, and then the subnet mask of /24, and the default gateway. The default gateway is the IP address of the router. Then we have an Ethernet adapter, 192.168.254. We also have a VMware because I have some number of VMs connected in my machine. They have also been assigned some IP addresses as well. Yeah, that's all. Do you still have questions?
As of now, there's no question. Okay, so I can see one. Vivian is asking, is security obfuscation the same to IP masquerading?
Security masquerading. In some sort of way, I could say yes, not unless there's someone who can go against it, because I think obfuscation, it's like hiding the real message behind some gibberish data. So the same way for IP masquerading, you could hide your IP behind another message or another number so that it cannot be identified. And for this obfuscation that you're saying is usually done in two ways. From the defensive side, from the offensive side, you could be hiding payloads so that they cannot be detected by defensive tools like the EDR and stuff. Is there anyone talking?
I'm not sure, but you can proceed.
Okay. So as I was saying, obfuscation is usually done in two ways. From the offensive side, it's done usually to hide payloads so that they cannot be detected by defense tools like the EDR, the antivirus. For IP masquerading, maybe we could search masquerading or government. Check the spelling. So for IP masquerading, the way I could explain it is, in my router, the one that is given a public IP in my network is the router. So the router has a public IP so that it can be able to be accessed from the internet. Now the masquerading happens in that we have, just as it has been explained here, we'll be given a private network IP address, or we could say a private network IP address that will be later on be subnetted so that we can have the number of devices connected to it. So in some way, I could say yes, obfuscation is same to IP masquerading, if I'm not wrong. Isn't it, Karim?
Yes, more or less the same, but it depends with the objective, right? but because with as we've seen with your what is it called with your Google search result, with the IP masquerading is basically you're trying to hide your internal network from the public, because whenever you're communicating with, for example, as Victor had shown with his ping result, it showed that it came out from 192.168.8 dot something, right? So that's the internal IP address. But once it gets out, it needs to be masqueraded so it can be able to have a, let me say, public face, so that it can be able to navigate the internet. So that's basically what it's saying. But when it comes to obfuscating, you're basically hiding everything, so it's not readable to anybody. So I think mostly it's focused on the intent, what you're trying to achieve at the end of the day.
Hello, Karim.
Hi.
I'm back
Yeah.
again. This is Isaac, and there's something clarification I really wanted
Okay.
for two things.
Mm-hmm.
One, the wireless and the website, for example. And I have, for example, at home, I have my wireless, and I
Okay.
want to hide. I want to hide that wireless, not by other people see it, whether IP address or even the whole name of the wireless. That's one. The other one, I want to have a hidden website, a website that cannot be seen by, can be accessed by anybody else. For example, it's my portfolio. I want to have that website, portfolio website, seen by only whoever
Yeah.
I share, whoever I share only.
Yeah.
So those the Wi-Fi, wireless, and the website
The
program of
website.
hiding them. Yeah, thank you.
Okay. So let me put it this way in simple terms. Let me start with the website. Whenever you get to Google, right, the things that are being kept visible are those websites which can be indexed. So index means searchable. So the only way for a website or a web application for it to not be indexed by Google is for you to instruct Google not to make it visible. So there are basically tools for it. For example, in WordPress, there are protocols where you can uh, select, for example, if you're using WordPress, there's settings that you can do where the website wouldn't be really indexed by Google. So that's the only way that you can do it. Yeah, to disable indexing for your specific website. Another way is to, for example, now this is a little bit more technical. There are these things which we call robots. So robots, before a website is being retrieved, Google goes and checks your robot. So it's a specific file which Google, let me say Google access it first, and then looks at set of instruction, what is allowed to be indexed or not, or what can I retrieve or what I cannot retrieve. And then from there, you can, the information is returned back to Google and then displayed to the public. So another method is to, let me say, provide specific instruction on your robots.txt file not to be indexed by Google. So it all falls down to indexing. So that's the specific answer. So for you to do it, as I said initially, it's either some web applications come with specific settings where you can disable that, and then it can be indexed by Google until you share the URL as you explained. Or you can also just include it on what is called, you can have specific tools. You can just Google search that to get tools that can help you to stop indexing of your specific website. So for the wireless question, it wasn't really clear, Isaac. in the perspective of, are you trying not to make it visible to other people who are in the specific area, or what are you trying to achieve?
Yeah, my goal is,
Yeah.
first of all, I want to hide the wireless name in that zone, that locality. That name should
Okay.
not be seen by anybody. You know, when that name is seen, is that's the time they click, and then
Yeah.
password now is that's it. Now goes to another stage. But now the name not to be seen, one,
Mm-hmm.
and then it should be hidden that way. The wireless cannot be seen by others except whoever I only help.
Okay. Okay, so to the best of my knowledge, I'm not sure if you can really do that unless if you just completely disable the Wi-Fi completely. So hiding the name, I don't think that's really possible unless if you configure your router to not broadcast the network. So basically not being invisible, even you yourself cannot access it, right? And that's not your goal. So your goal is for the network not to be accessed by other people. Now that become we go back again to your settings, how you configure your security protocols, how you set up your passwords for accessing the Wi-Fi itself. And yeah, I think that's it. And also Lauren also added on top of that, uh, she said you can hide the router's SSID. So that's another point. So I guess I'm wrong because I'm not really an expert in the wireless networks. But yeah, so mainly you can do that, or you can what is it called? You can another best practice is to, let me say, have layers within your network. So the public and the private layers. I don't know if that's the correct term, but basically is one could be accessible to anybody. So that could be your guest network, right? And then the other one could be just accessible to you and anybody who is under it. I mean, under your family and network. So that's another best practice, but also using the good password policies and things like that. But there's somebody who had something to add on top of that. I'm not sure who it
Hello,
was.
hello. Before you proceed, do
Yeah.
you mean that there is a netting and subnetting of the internet?
No, so for example,
Yeah.
with your Wi-Fi, there is a way to broadcast multiple um let me say names. So for example, you could have Isaac Home and Isaac Guest, right? So those are just settings which you can do on your router. So for the password get, I mean Isaac Guest, it can be accessible with anybody, and also you can configure the amount of traffic or let me say internet packets that that specific SSID can have. And then you can have Isaac private. So that one is just for you and anybody else who is within your let me say network or family or local area can access with the help of passwords to get the authentication pass of to your wireless network.
So now, and the private one, you mean
Yeah.
that it cannot be seen by others?
So for that one, from my method, the one I was just explaining, it can be seen with everybody. But Lauren also explained here that you can actually hide your router SSID. So that's a solution where nobody can see your Wi-Fi name,
At the
if I'm
same
not
time,
mistaken. Yeah.
the routers, are they different routers? The one for the private and the other one,
No, it's
or are they the same router?
yeah, same router.
Okay, okay, thank you.
Yeah, it's all about the configuration. Lauren, I'm not sure if you want to explain further about your answer. I think Isaac will really appreciate it. So if you can unmute yourself and explain, that will be perfect. Lauren, I'm not sure if she's in the session. Oh, okay. So Isaac, she has mic issues. So Lauren, if you can just put some sort of explanations on the chat so that Isaac can follow and help him with what he wants to achieve, I think that will be greatly appreciated. Yeah, but apart from that, anybody else who has a question about networking, so Victor can answer any burning questions? While we're waiting for your questions, one thing which I could also point out is networking is very important when it comes to cybersecurity, because whatever you do on the internet or on your machine, it all falls down on the network level. So it's very important to understand things like how communication occurs, how devices communicate. I think Victor had shown some various examples of that. So the
Hello,
3TCP-way
excuse me.
handshake.
Once more again, there's a concern I'm having here.
Yeah.
There are the applications at time I applied and certain jobs from my email, and some of them
Okay.
are all I have applied online through another, the portals for applications that they normally post by organizations. So what happened? There are scammers who do try to behave like as if they are the same organization that I applied sometimes back,
Yeah.
and then send me invitation with some kind of conditions, and which later on, when detected, it has been scammers. But they
Yeah.
behave like, what I'm doubting is how have they noticed that I applied that particular job title, and they have, from my email or from my application portal, wherever I applied the system, and it is only that I thought it is safe, but later on I realized that I'm still, not knowing how have they accessed that I applied that kind of title and they're inviting me, and how have they noted that from either the system or from my email, how have they accessed or noticed they were not with me, or when I was applying.
Yeah.
So how have they noticed? Where have they intercepted? Have they intercepted the system where I applied, or have they intercepted my email? I could not know how have they, got that information of mine, and
Yeah.
then inviting me for the fake job. Thank you.
Okay, welcome. So thank you for your question, Isaac. So before getting back to you, let me allow Lauren to give you the brief explanation on your initial question for the Wi-Fi and how to hide it. So Lauren, please feel free to unmute yourself and try to explain it to the best of your ability on how Mr. Isaac here can, hide his Wi-Fi.
Hello, can you hear me?
Yes, loud and clear.
Awesome. So actually, this process I learned in Cisco that you just log into your router's like admin port or something like that, your router's IP address, then log in using your admin credentials. Then you will like after logging in with your admin credentials, you can navigate to the wireless, depends on the router, the names defaults. Then you can disable the SSID broadcast. So every time you want to add a new device to the router, you just manually you add the SSID and the password to connect. I hope I've answered Isaac's question.
Well, I think you have, but I think it's a little bit technical. But once again, if you have any resources, if you can get in touch with Isaac to share the resources so that he can achieve his goal, I think that will be perfectly fine. You can look or ping each other on the group, and then you can take the conversation on your private DMs, right? And then take it from there. But Lauren, thank you very much for the explanation. Yeah, so you can just pop up a hi on the WhatsApp group so that Isaac can be able to, get in touch with you privately.
Awesome.
Okay, great. So one of the question was from Lorna, so it's a little bit, I think, off topic. So Lorna, if you can just inbox me, and then I'll provide a little bit of explanations on that, how you can access the CTA platform for you to practice your labs and assignments. So just inbox me on my WhatsApp.
Hello.
Yes, Isaac.
About the scammers, how have they intercepted? That's where I could not clearly get it, please.
Yeah. So
I'm okay with it.
We started first of all with the Wi-Fi to clear that Kwanzaa,
Yeah.
and
Okay.
then we get to the second question that you had. So don't worry, we're answering that one. So in simple terms, basically, so this is the answer to your question. Is basically these two things that have happened there. So number one is social engineering. That's usually the easiest way to do it. But also not only social engineering, but also with the aid of something which they call spoofing. So basically, spoofing is changing your IP address to appear like the legitimate IP address that you had initially, for the company that you're applying for, rather. So they'll spoof their IP address, and then once they're done with that, they now perform the social engineering. So those were some of the emails that you have been receiving, Isaac, on your email. But the rest is a little bit more technical. It will need, more hours. I think Victor wanted to add a little bit on that.
For the one that he's talking about, this email spoofing.
Yeah, the spoofing and phishing. If you have anything you want to add on top of that before we proceed with the other questions for networking.
I guess you have answered it well. It's usually mostly about email spoofing and social engineering. You could find the website, maybe even the one you used to apply for the work. It could be a clone. Maybe they were just having something like, let's say it's called a bait. Maybe if you send it now, they start sending you the scam messages repeatedly on a loop.
Okay. Thank you for that. And then there's a question from Brian. I'm not sure if you've seen it on your side, but he said, I'd love you to explain how one gains access to a network, like a basic overview. Scenario like an alleged group from a country gains access to a server in location G. A basic overview focusing on networks, more of a theoretical overview. That's what he's looking for. That's Brian.
Okay, I've seen it. So to answer your question, I will use just a simple example. Let's say I'm a bad actor. I'm a threat actor, right? I want to attack
Sorry,
a
Victor.
company.
Excuse me.
Pardon?
You have access to what is it called? Your whiteboard. So if you want to explain using your whiteboard, the whiteboard rather, then feel free to do so. You have access to that.
Okay.
Yeah, so you can use that to explain, draw, and things like that, so that it's a little bit simple for them to grasp the concepts while you're explaining your answer. Maybe that might help also.
Where is it located?
It should be down on the bar where you have participants, chats, reaction. You can check on tools, I think, or more. Yeah, click on more, and then you can see whiteboard.
I'm not seeing whiteboard in mind.
So do you see on your screen? You're using a laptop, right?
Yeah.
Yeah, I think it's going to be on your right hand side as it is on mine. You'll see the three dots written more. So click on that is when you're going to see the whiteboard, I think. Because I've allowed you to share whiteboard on your side. So just try and check the settings on your screen, or I don't know.
Okay.
Can you see it?
Not yet. I'll just use an online one.
Okay, that's fine.
Okay. Okay. Well, I'm looking for the whiteboard. I'll just explain it in a shorter way. So you're asking how I am able to access the network, right? So let's say I'm a pen tester. I'm located in Kenya, but a company like Vodafone gets to hire me. They want me to do a pen test for them, but I'm currently located in Kenya. But they have a website, maybe we could say Vodafone.com. Just like you have heard, there are people who are talking about reconnaissance. So I will do some enumeration to the website to get vulnerabilities and different endpoints that are vulnerable, maybe let's say to different type of attacks. Maybe we get an attack like resource code execution. By an resource code execution, is an attack type whereby me as an attacker, I'm able to execute commands in the web server without being there, right? So I've been able to access the website from Kenya, but when I'm here in Kenya, I want to access the internal network. Now, from this website, from a pentester point of view, we call it a jump server. So I've been able to access the Vodafone organization from their website. Now, through their website, I will now scan their network. Now, let's say this is the website, right? That's the website. And there are, okay, let's put it here. Sorry for my handwriting. We could say this is the attacker. And attacker, this is my machine. And then this other one, we talk about, this is the Vodafone website, right? So from my attacking machine here, been able to access the website, did some enumeration, and then I got an RC vulnerability in the website. Now from the website, I get to access the network. And by that, okay, for website, as you all know, for us to have a website, they are usually hosted. Maybe we say it's hosted on a web server with an IP address of, let's say 192. These things are boring. So it has an IP address of 192.168. Let's say 80.1. That's the IP address for this web server, right? So from this IP address, I could do further reconnaissance on it to get the subnet it's under. So from this subnet, then I could be able now from the website access other devices in that subnet. And then from this subnet again, we could also get details of the entire network so that we can find other subnets in the network. Now from this, as you have seen, just from this simple website, we have been able to get access to the first subnet of the Vodafone organization. Then from that subnet, we get to do further reconnaissance, and then we get other IP addresses or subnetworks that we can pivot from. We can pivot from one subnetwork to the other. Now, for me to be connected, let's say we find another subnetwork called, let's say it's 192.168, 192.168, let's say .80.0 slash, let's say 16. This is another subnetwork that's within Vodafone. For me to be able to access this subnetwork, we'll have to compromise another device on this network, then be able to access it from another device. Let's say this we call it to be 81.0 slash, maybe we call it 14. So this was our first subnet that we accessed, that the web server is hosted on. From this web server, we get to do further and another subnet. We connect these two subnetworks with something we call a proxy. So we have a proxy. We'll be having a proxy between this subnetwork and this subnetwork so that we can be able to communicate from this subnetwork, internal one. But when we are doing this, remember, we are attacking from Kenya. We are not in the organization. We just started by doing a reconnaissance, get a device, compromise it. From that device, we pivot again through the proxy to the internal subnetwork again. Now from this subnetwork, we could get another subnetwork. We put up another proxy, then we continue to compromise the entire network. I guess I've answered the question now. Brian, have I answered you?
I think you have, hopefully. But also, let me just give a simple, a more simpler explanation in terms of that. Let me see if I can open the whiteboard. Okay. So basically, what Victor was trying to explain is, so assume that you have your server here. So this is your target server, right? So let's just put TS to mean target server. So what usually happens is in a target server, the purpose of having servers is it tends to host services. So let's call that SV. But apart from services, it also hosts applications, right? So any application that you see currently, that could be a website, whatever the case, it's running behind a server. So let's assume that we are talking about the web application. So the web application will be sitting in front of the server running on port 80. That's the port that usually all web applications are running. So from here, there are two ways on how you could get access into the server. So either number one, let's assume that the server itself is running multiple services. That could be one of the services could be SSH. So that's port 22. It could be running another service called FTP, right? That's file transfer protocol. That's usually running on port 21. And then finally, let's say it's running SMB, right? So these are different services which the server is hosting, plus a web application being hosted by this application. So what Victor was explaining, that one of the method is you could get access to the back end of the web application. And then once you've gotten the back end access of the web server, so that the administrative access, you still need to get access directly into the server. So that's where he was talking about RCE. So that's remote code execution, which gives him direct access from from the web application into the root, or the, let me say, administrative access to the web application. So that's one bit. The second bit could be you use the tool called Nmap. I'm sure most of you are by now aware of that, to scan the whole server to see what services are open. What ports are open and services associated to that port. You could find most likely these are some of the services running, and then you check if some of these services are vulnerable to different attacks. If they are, you try to exploit them to gain access once again to the server. So those are the different ways on which a network can be exploited. As long as the asset is accessible on the internet, it's vulnerable to different type of attacks. So that's just a simple type of explanation I wanted to add on top of what Victor was explaining. Okay, so we can go to the next question. Steve is asking, what is a proxy? Victor, I think you can answer that one.
Oh, Steve, you're asking what's a proxy? Okay, let me help you to understand it well better. We are two foreigners. Maybe let's say I speak Spanish, you speak English. You can't understand Spanish. Between the two of us, we have somebody, an interpreter. So when I speak Spanish, the interpreter takes in the language, he interprets it to English so that you can understand. The same way, for a proxy, in my example, as I had shown you earlier here, so what happens, this proxy acts like an intermediary between these two subnetworks. This subnetwork here is different from this. For the devices in this subnetwork to communicate with devices in this subnetwork, they need an intermediary that can be able to connect the two so that they can have seamless communications. For anyone who is doing red teaming, you'll come to get to know devices like tools called SOCAT and NCAT. They usually help in forming the proxy. You could think proxy just like an intermediary between the two so that they can have seamless communications. Because if we don't have this proxy, devices in this network can't be able to access these devices. Why? They're both in different subnetworks. They have different configurations. This subnetwork will have a different configurations on compared to this subnetwork, so they can't communicate. However, if you bring a proxy between them, it will be easier to link the two so that they can communicate easily. I guess I've answered the question, Steve.
I think you've answered that question very nicely. And also, Vivian, thank you very much for your explanation. That side, she also chipped in terms of that explanation. There is another question from Collins Mutua. He's asking about, okay, I think this is a little bit off topic, but he has a Windows machine where he's trying to ping it from his Kali. How can he do it?
I think I've answered in the DM, but I will just answer it again. Okay.
Okay, awesome.
Just the way I just said, you could find that the network configuration in your VM could be the one with a problem. Maybe, for VirtualBox, we have two way of configuring network. We have a bridged network and the NAT, if I'm not wrong. So if you have a bridged network, that is the one that will be easier for you to ping your Kali Linux and Windows. But for a NAT, it's like you're secluding you're secluding your VM to another network, whereby now the laptop will serve maybe as an access point to the virtual machine. Yeah.
Thank you for that. Fred is also asking on the traceroute command, the hops that we kept on seeing, are they like servers or what are they?
You could say, okay, not all are servers. How can I explain it in a better term? Okay, how many have interacted with maybe Tor network websites, the onion ones?
They're all beginners.
Oh, sorry. Okay. So not all are servers, but some are. What I was just showing you, because the example, the one we used, like the trace route that we did, let's say 8.8.8.8. My router is not a web server. I mean, my router is not a server. That's a router. You could think of a hop. It's like steps. You are climbing you want to go to the top of a building, so you have steps to climb on. So the hops is like there are steps. You could find maybe this is a server, there's another one, it's a router, a switch, like that. Not all are necessarily servers. Yes. Is that well understood?
Okay, thank you. I understand. I want to ask another question. Like, can't you have direct access, like from in your case, like from your router to the Google website directly? Must you always pass through those hubs?
Yes.
Yes, you definitely
have. Because the network, you see, the internet it's a big community. So you can't go and so if I want to access Google server, just as I said, they don't have usually one server. You see? So let's say I'm from Kenya, there's another thing called regions, right? So Google servers, they have mirrored their DNS servers in such a way that if one DNS goes down, another one will pick it up as a backup server. So in case one goes down, there's another server. You could find that the time I was accessing google.com from my website, what happens behind the scenes, it's a lot. First, there's something we call a DNS cache that will be checked. Do we have google.com DNS in our cache? If it doesn't have, we will contact the internet so that we can register it into our network and be able to access.
Thank you for. I don't know if Fred, your answer. Okay, you've been answered. Rather.
I've answered. Thank you for that.
Okay. So, okay, let me just try also on my side to explain it in simpler terms. So basically, it's like, for example, you're trying to move from your home place to town. Definitely, there are different stops in between that you need to pass through in order to get to town. So, in order for you to get to your destination, which is google.com, there are places which you need to pass through in between the way. So these are like the mini stops along the road. So it doesn't mean you generally have to go through all of them, but the most important stops, definitely you'll stop on those points in order to reach your final destination. So generally, that's the analogy in simple terms. And then there's a question, beautiful question from Isaac, Mr. Isaac, sorry, my bad. So he's asking, how can I easily identify threats, vulnerabilities, and risks from the network?
Do I answer it or do you answer it?
Hey, you may go on. You're the boss.
Okay, sorry. So just as Karim had said earlier, one of the tools you can use is Nmap. Nmap has actually a lot of powers. You could scan an IP address or even an entire subnet just with, there's something called, let me type it and then I'll show you. Nmap, let's say we have an IP address, and then you can use script val. What you simple command that will scan the IP address for services it has. Then once the services have been found, it will then look if they are vulnerable to any type of attack. I guess that is one of the tools. Another tool we use, it's called, what is it? I think it's disappearing. We have Nmap that does vulnerability assessments. Nessus. Nessus is another tool that does that too. You could use it to scan for vulnerabilities. Is that well understood, Isaac? But your question is more based on there are different type of tools you can use for identifying vulnerabilities. Hi.
You said Nmap. What is the other one?
Nessus.
Nmap or Nessus?
Please. Okay, Nessus.
Yeah.
Yeah.
So what of that's vulnerability? What of their risks and threats also? Before vulnerability, there are threats, is it not?
Yes.
How can I avoid those risks? I mean, threats, or how can I protect that risk from my system?
How do I answer it? Okay. Vulnerabilities come by exploitation of threats, isn't it?
Yes.
Okay. For these threats to be identified, we have to first do something we call scanning or reconnaissance. We gather information. Let's say you see. So before I get these threats, I'll have first to do some scanning to this, reconnaissance, maybe on the network, find different type of devices, look at their configurations. How have they done it? Do they have loops in their configurations? Those loops will act as vulnerabilities that I, as a pen tester, can later on come and then exploit those loops within their configurations, and then they get to serve me to attack your network. Have you understood, Isaac?
Yes, yes.
Okay.
Okay, thank you for that. I don't know if I should explain it from my perspective, but I think that was great.
You can add, especially on
Yeah,
the risk
okay.
part, on the risk, the forward risk that you can expect. For example, if one or two things happen, what are the foreseeable risks? You can shed light on that.
Okay, so that's a very broad question to answer, but let me just put it into simple terms, right? Let's just the whiteboard to load. Okay, yeah. So basically, what happens is whenever you get a server or an IP address, so this will have your IP address, so that will be something like 192.168.2.1. So this will be your server. The first thing that you'll do is, as Victor had explained initially, is to gather information about this server. So how are you going to gather information is through scanning. So you need to scan this whole the server to find what open ports are there. So that's the first bit. So that will be, let's say, for example, port 22, port 21, port 80, it could be port 443. So that's the SSL. Sorry, I'm just not writing properly. And then then probably you could have port, I've forgotten the port number for SMB. I think that's for something. 449, right?
Yeah.
Yeah. So you could have 449 open. So these are ports. These ports are running services. Each port has a service that is running. So port 80 will run HTTP, right? So that's HTTP. Port 443 will have HTTPS. So basically SSL, that's what's running to make your connection to the internet and web application secure. You'll have these two ports open, 80 and 443. And then port 21 will be FTP. And then port 22 will be SSH. So this one gives you secure connection into the server as an administrator remotely. So that's the function of port 22. And then 449 will be SMB. Now from here, using your Nmap tools, it will give you also the services, the version of the service that is running. So from the version, you check, let's say, for example, SSH is running version 1.9, FTP is running, let's say, version 1.1, HTTP will be running, let's say, just for example, version 8, and then SMB will be running, let's say, version 1.5. So once you see these versions is when now you go and Google search if there's any vulnerability of this service based on the version it is. So that's why we keep on having something called updating your computer. So updating your computer, basically you're changing version. So as a system administrator, you'll be updating the service version. So for example, if there's a vulnerability that has been found that will be associated with version 1.9, they're going to fix it, provide a patch, and then move it to version, let's say 2.0. So whenever somebody tries to hack SSH based on this version 2.0 using a vulnerability of version 1.9, it wouldn't work. And that's where they tell you, okay, your system is okay, you don't have any vulnerability, you can't be hacked. But once the hacker comes and find out that there's a new patch, let's say the version 2.0 has been released, but unfortunately you as a system administrator were lazy enough to not update your version and you're still in version 1.9, here is where now they try to hack your system. So that's how you identify vulnerabilities in different system or assets that you're running in your network. So that could be your router, that could be your endpoints, so that will be your computers, APIs, etc. This is what happens behind the scene from an attacker or defender's point of view. Now, the risk associated will depend with the problems that you're meeting. So let's say, for example, if you're running version 1.9, one of the risks that could be associated with it is the hacker could be able to gain access to your server remotely without even needing the credentials, right? So that's the risk of it. And once the hacker is in your server on the back end, they could do anything that they want. They could probably change the administrator's password so that they could be the only one who has access to it. They could create new users on the systems and give them administrative rights. So that's the risk associated with it. So it all depends with the problem that you've managed to discover. So that's why initially I said your question was too wide. But in a simple perspective, this is what is happening behind the scene when a hacker is trying to hack a system or exploit a vulnerability. Okay, so let's see if there's any other question. So Alvin is asking, explain VM sprawl, and how to protect yourself from it.
I guess VM sprawl, in simple terms, I could say it's occurs when the number of virtual machines within our virtualized environments, they grow rapidly and then they become difficult to manage. So when you have this uncontrolled VMs in your virtualized environment, you could find that you are having, how can I say it, increased management overheads, and then you have waste of resources, and then you'll be having increased cost. Sorry, is there anyone speaking?
No, I said exactly. Yeah, I'm agreeing with what you're saying.
Oh, okay. So we could having security risks because some of these unmanaged VMs can be more vulnerable to security breaches because you see, when you had your first VM, you had done a lot of configurations to prevent any sort of VM attacks. So when you get to have more VMs, there are some you'll get even you yourself tired of configuring and forget. There are some VMs you didn't configure well. And then an attacker gets to into your virtualized network through that unconfigured VM, and then from that unconfigured VM, you will be able to pivot to the rest of the VMs, and later on your entire virtual environment will be compromised and become completely damaged. It occurs due to a number of VMs just growing, and then they get to be attacked, and then you find some are badly configured than the others. Is that well understood, Alvin?
I think that's perfect explanation on that perspective. I think you've explained it very well. So just look at it at the perspective of, let's say, for example, the likes of Uber, the likes of Airbnb. They have a lot of systems that they are running behind the scene without even you realizing it. And most of these companies are operating in different regions. So different country, different region will have different requirements. So they'll have to open up a different virtual machine or virtual environment to cater for that region. So managing all this from an administrative point of view, it's very complicated. And as Victor said, it's going to create more loopholes, more risk in terms of the organization's security. So in simple terms, that's basically what that is. So I was trying to explain it in a practical point of view. Then there was a question, I think, from Gideon, and then he kind of withheld from it. So Gideon, if you have any questions, feel free to shoot. This is your time before we end the session. Gideon, are you okay? Okay, so I guess he's not available. I'm assuming that, but okay, Victor, so let me just give you 2-3 minutes or so that you can give your final remarks, and then we can end the session here.
For my remarks, I could say thanks for the time and the opportunity to educate you guys because even me, I'm not perfect. You're not perfect. Cybersecurity keeps on evolving, so even me, I keep on learning. But my last remarks, I'll just give you a short command that you can be using to get Wi-Fi networks. Maybe you want to get access to maybe a network that you don't know the password, but there's someone's laptop that is connected to a network. This is for educational purposes. So you can see the command is netsh show profiles. Yeah, this is the good thing of networking. I guess there's someone who talked about SSID. These are SSIDs for different networks. So I don't know the password for this Morse code, so I can use it show profile. Then you take the name. Then you say key is equal to clear. And then you have our password here, key content. That's my remarks.
Thank you very much for wonderful remarks, Victor. We really appreciate the. Hey, you've you've taken me way back in the days when I used to do this. So really, thank you for that. We really appreciate it. So, guys, I think you've learned something. If you've missed it, the recording is going to be there for you to go and check it out, and check out your passwords that you've connected to previously and you've forgotten them. So thank you very much for being in this session and spending time with us. We really appreciate it. Victor, thank you very much for being here with us and, showing us the cool stuff that you've done today. We really appreciate it. And hopefully next time you'll be here with us. So thank you very much. The labs will be released soon, right after this session. So just be on a watch out for that, and then you can put everything that you've learned in this session and your personal research into action. So yeah, I must say thank you very much and see you in the WhatsApp group. If you have any other questions, probably I've missed some of the questions here, feel free to ask them on the WhatsApp group. We'll try to answer them to the best of our abilities rather. So thank you very much and have a lovely afternoon. Cheers everybody. Bye bye.
Bye.